Very good morning to everyone. Moving forward, we are going to discuss different object types that exist in Python. Right. As I told you before, there is no data type declaration. So you won't declare type of your data in Python. Right. So hence, there is no data types in Python. Instead, we are calling them with a different name called object types right now. So everything is considered as object. Among them, these are the different objects that we have in Python, like numbers, string, list, dictionary, tuples, files, program units, and set. As far as the numbers are concerned, when it comes to the numerical computation or scientific analysis or statistical analysis, we use numbers right now. So in that sense, the Python also has the data type of object type of numbers. So when you want to use numbers in Python, they are coming under the numbers object type, right? As far as the numbers are concerned, unlike C and C++ or other language, there is no minimum and maximum range. There is no minimum value and maximum value. You can go up to 36,000 digits. Up to that, you can have a number. Single number can have that much big range. There is no limitation in that. So when you, again, you won't declare the numbers in Python. Instead, you just, when you assign a number to a variable, automatically that variable object becomes a number object, right? It is in that way. So Python support decimal, fractional, complex, every numbers that we have in the mathematical world, all are supported in Python, right? Then strings. The strings are very important in programming because we used to display messages, and many times we want to write something to the file, we convert them into string. Like that, the string is an important part of every programming language. Similar way, Python also has that one. So when you assign any string value to your variable, automatically that variable become an object of string, right? Again, you won't declare any, like there is no boundary for your strings. It's not like you can go only up to this much character of the string with this much character. No, not like that. You won't define it. So you have you can use entire memory of your RAM to store a string. So there is no stopping point in that one, right? So as we have for numbers, right? Then we have list. The list or something similar to array in other programming language, like we have arrays in C, no? Similar to that. But difference between list of Python and arrays of other languages, when you declare an array in other language, all the element in that array are of same data types. If you declare an integer array, all of them are integers. If you declare a string array, all of them are string. When it comes to Python, you have the independent. You can have object different, that is arrays with different objects like numbers, strings. Everything can be mixed together, right? So they are ordered. They are identified with an index. So it is whatever the properties that we have for arrays, almost most of them are supported in list, right? So when you want to compare the list with other options that we have in other language, you can compare that with array, right? Then we have something called dictionaries. Dictionaries are in another, you cannot call them as a list. They are like a mapping. So here, the collection of objects are identified with unique key. So every objects in dictionaries has a unique key and respective key as a key value, like that. Here I have given an example. So we have two keys like vehicle speed and query switch request. the vehicle speed is having the value of 120, and price which request is having the value of 7. When it comes to dictionaries, they are unordered. So there is no proper, or like you cannot sequence them. They can be in any order. Only you can fetch them using their key. That is I think, the method used in dictionaries or mapping. So you are mapping a key with a value. Then when you want to, when you want the value, you will address it. You will find it via the key that you define. Right? It is in that way. Then we have a tuples. The tuples are something different. They are immutable list. It is similar to list. It is similar to list. You can have mixture of different object type like number, strings, like that. The only difference is list or mutable. Mutable means, what is mutable? Mutable means you can change their value in their respective places. So when you want to change the value of element that we have in the list, you can change it. That is possible in list. When it comes to tuples, it is not possible. Right. So they are unaltered list. We can call tuples as unordered list, that you can use it in the program. How to use it, that we will explore in later part of time. As we have the file IO support in other programming language like C#, C, Java, and every other languages, they support file IO right now. When you want to store something in the hard disk of the computer, we have to follow the file system. To work with the file system, we have a set of library functions in every programming language. Similar to that, we do have the set of library functions for file IO in Python as well. Right. Here is some syntax. An example is given. So you can say like file pointer is equivalent to open is a function used to create a file. And then the name of the file that you want to open or create. And then the mode. If it is reading, you can use R as a mode. When you are writing, you can use W as the writing method. Another data type or object type that we have is function, modules, and classes. Those are a little bit advanced. I'm not going to touch them here now. So we will discuss them in detail later point of time. There is an object type as well called program unit, which is nothing but the building blocks of a program, like functions, module, classes, like that. We will study them in detail later point of time. Then we have a sets. Sets are like a collection of objects again. But you can ask me questions. We have a list and tuples. Why we have a sets? Sets are another set of collection of data that we have in the Python. So in sets, they are also a collection of entities. You can apply, you can use, you can what do you say? You can process. Otherwise, instead of using a word process, the right word is you can work with sets. There are library functions to work with sets. Those complies the mathematical rules that we have, that we know with respect to sets in mathematics right now. So that means union, like union sets, and then different sets, like that. Whatever that you used to do in mathematics with respect to sets, no, that you can perform on these data. They are again a collection of data objects on which we are employing the formulas or expression related to sets. That's all, right? So these are the different object types. I have given you a high-level idea here. We are going to study them. We are going to have an overview. This is just an introduction. Then we are going to have an overview. Then in later point of time, we will explore each and every object type in detail, right? So among them, very first thing that we have is numbers. As there is no type declaration in Python, objects created is purely based on the syntax of expressions. The moment you assign a value to an object, At that point, you define the object type. Whether if you give an integer numerical value to a variable, at that moment you define that variable as a number objects. When you give a string value to a variable, then you define that variable as a string object, right? Like that. Here there is no separate type declaration. That is the things that we have to keep in mind always when you work with Python data, right? Operations that are related to the type of objects are only allowed. For example, I am defining an objects of type string by giving a string value to a variable. I can only call the function those are related to strings. For example, upper, converting that string to uppercase. Otherwise, checking whether that string is an alphabetic or not. For that, we have a string function called isAlpha. Right. So only the functions related to the strings can be used. You cannot bring functions, those are related to numbers. Those are related to lists. You cannot bring them here. Right. So that is the point that we have to consider when we use objects in Python. When you define particular objects of specific type, only functions those are related to that objects can be called. You cannot call the functions of other object type. No, that's not possible. Again, in Python, for addition, they use plus symbol, mathematical plus symbol for used for mathematical plus, right? Plus symbol is used for addition. And when you want to go for multiplication, you can use star. When you want to find a power exponentiation, in that sense, we have double star. So maybe in other programming language, some of them, they are using a caret, like that we have operators now. Here for power, they use star star, double star is used. Random module is used for random number generation and selection. I think here it should be, sorry. So there is a library module called random. It is a predefined module. When you import that module in your Python program, you can call a function called random that can generate random number. We have other module. We do have a function for other mathematical functions like sine, cot, tan, and the square root. Right. There are sophisticated numerical functions. Mathematical functions are aligned under the library called math. Math is a library. Random is a library, right? Random is a library, and then math is a library. Random is for random number generation. Math is for all mathematical functions like sine, cos, absolute value, square root, like that. You can call those functions if you include math library. Python also support sets and booleans. As I told you before, we have support of sets and boolean in Python. What is Boolean? Boolean is nothing but yes or no, true or false, like that, right? So they are coming under the Booleans are aligned under number. So these are the different nodes that different points that we have to remember when we deal with number in Python. So here we have a problem statement. We had studied something about numbers now. So for that, to register that in our brain, we have to try something practically, only then that will register in our mind. For that, we have two problem statement. One is generate 10 different vehicle speed, 10 different vehicle speed sample using Python. So we can use this as a lookup table to feed our vehicle speed signal that we have in our simulation or rest bus simulation that we do know. So when you simulate the vehicle behavior, you have to vary the vehicle speed right now. To vary the vehicle speed, you should have some numerical value. You should follow certain pattern, right? For that, For that, in order to generate that vehicle speed, we are going to use this program. We are going to generate some 10 different vehicle speed using Python. For provided the sample should represent sine wave. So those 10 sample should represent a sine wave. When I plot them, I should see a sine wave structure in them. So only then I consider that as a successful output right now. So that is the first problem statement. So from this problem statement, what we come to know, we have to generate 10 different sample. 10 means it is a sort of range 1 to 10. That means we have to use some sort of loops to achieve this one. That is one point. Point number two, it cannot be a single variable. It should be a list of variables, right? Now, list of vehicle speed. In that sense, probably we may use list, right? How to create a list and other things. I will give like a high level intro. With that, we can proceed, right? So then in that loop, we have to generate sine samples. For that, we require a function called sine, right? To generate a sine wave, we have a formula like 2 pi into 2 pi f I divided by fs. This is a DSP formula, no? To generate a sine wave sample, discrete sample, right? So sine of 2 into pi into fi means information signal frequency divided by sample frequency. Then you can multiply that with your rider. That means a range of values from 0 to 10, so that you will get a 10 different samples as an output, sine wave sample as an output. Maybe they will have the range between 0 to 1. You can convert that by multiplying with an VM, that means voltage value, so that you will get a sine wave sample that can be used as a vehicle speed. Even from my view, we can multiply Vmax, which is in our case, maximum vehicle speed in our case is probably 250. So you can multiply 250 into sine of 2 into pi into I, that means rider into fi divided by fs. In our case, we can generate a frequency of 1000 hertz signal, so that we can say like 1000 divided by sample frequency as some 8000, something like that, so that we will get an 8 sample. Within 8 sample, if we can see a waveform, right? That we can do. Number two, generate a random number vehicle speed using a random module. So we already know that for random number generation, we have a random module. We can use that. So these are the two assignments that we are going to do now. To do them, I am going to use, initially we can do it via modules, no problem, right? So let me notepad gen vehicle speed dot py. This is the module, right? We have a, so initially what we are going to do in this module, we are going to create a list, empty list. To create list, we say vehicle speed samples, right? Is equivalent to, for empty list, you can say like this. This is called as, when you use square bracket, that means you are going to create a list. But this list is empty. We are going to populate that list. For that, for rider in range, you're going to 10 sample only, no? So 0, 1 to 11. Sorry. Vehicle speed underscore samples of dot append we have to find out the vehicle append sign off. Before that, we have to import math. Math dot sine 2 into math dot y into rider into, in our case, it is 1000 divided by 8000. Right. This will give a some sine sample. So, but it should be multiplied by a V max. That means vehicle speed max, VS max. Right. So why I am using 250? In typical speedometer, you can find the vehicle speed in the range of from 0 to 250. That's why I am using the maximum value as 250. And then why I use math.sine? The sine is under the math directory of Python. So we are using like that. Then why I use 2 into pi into Fi divided by Fs. That is formula to find out discrete sine values. Those who studied DSP, they know about it. For that, 2 into pi into the rider value is number that is index of your samples. Then multiplied by Fi, the information divided by sampling frequency. When you give that, you will get a discrete sine sample. So that those are populated in this vehicle speed sample. That means that a list will contain that one. All right. Finally, I am going to print that. To print that, I'm using, I think we can even print it here. Print vehicle speed samples of rider. Right. I think this will do. This is for sine wave generation. Let me recap. First, to use the math library, I am importing it. Then I create a empty list, vehicle speed sample list. Then I run a loop 1 to 11 because I want to have 10 samples. The 10 sample can be achieved in Python only from 1 to 11 because Python always use 1 minus the upper boundary. See, when you say it is starting from 1, when it is when you need 10 sample, you have to give 10 plus 1. That means 11. Because it always use the value from the beginning value to 1 minus the upper boundary. That's why I'm giving 1 to 11. After giving it, then we find out append is a function to add items to list. Right, this is an empty one, no? So I'm adding the items one by one. Then I find the sine discrete sample. For that, I use vehicle speed max multiplied by math.sine. Sine is a function belongs to math library. That's why I use like that. Then pi. Pi is also defined in the math library. That's why I use math.pi. Then rider is the rider variable. that we use, then Fi divided by Fs, information frequency divided by sample frequency. Here I assume my information frequency is 1000 and sampling frequency is 8000. Maybe this is also having a reason why I'm choosing that sort of frequency, because within I'm defining only 10 samples or so. No, within 10 sample, I can see a sine wave if I define frequency like this. That's why, that is the reason. Then I am printing what I generated. No, that sample I am printing using the rider thing. That's all. Let us see how things goes in the real time. Let us run this program and see what happens. So this is the corrected program. Here we have the initially empty list is created. Then we are running the range for loop in between 0 to 10, which is nothing but 0 to 9. Index will be 0 to 9. So 10 sample we will get. Right. So we append the list with the discrete sine sample, and then we print the sample again. That's all. Right. So we generated 10 different samples of vehicle speed. Right. And it represents a sine wave. Then generate 10 random vehicle speed using random module. So they are asking us to create 10 different random vehicle speed. They are random in nature. But provided, first we have to understand how the random numbers are generated in Python. Then we can proceed. Right now, for that, I bring Python interactive prompts, then import random 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 oh, random dot random. I think this is the, so they generate a number in between 0 to 1, I believe. So in order to get the original vehicle speed, we have to multiply that by 100, right? So what I do, I in the range 0 to 10. I believe in random dot random is the function to be used to generate a number, but it generate always the number in between 0 to 1. So in order to convert that into a complete number, we can multiply that by 100. 100 multiplying 100 by that will give you a two digit value right now. So for that, let me create a module now. Control Z. Plus plus. Can I bring a notepad plus? I think it is not coming. Notepad. Random vehicle speed dot path. This is the module name. Right. So import random, then for rider in range 0 to 10. Before that, we need a empty list, random vehicle speed, empty list we created, print random vehicle speed of rider is equal to random dot random of dot random of, then multiplied by 250, because that is our vehicle speed maximum, right? When you get 1, you will get a maximum speed, right? So then print random vehicle speed. No, I think it is vehicle speed dot append, right? Right now. That's all. Sorry. Python random vehicle speed 0 to 10. Invalid index. Syntax, perhaps you forgot a comma. For rider in range. Rider in range 0 to 10. Oh, sorry. Right. So we get 132, 133, 210, 72, 78, 131, 16, 90, 21, 92, 92. All of them are right within that range, right now. So this is how you can generate a random vehicle speed or sine wave sample using Python mathematical library and random number library. Right now. Today I end the session with this. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.